Okay, kids, we're back here. Section 2.4, practice question 2A. And we want to find the magnitude and direction of net force in each situation. Because if you look at this, kids, net force, look, it's a vector. I need magnitude and direction. And it says a cannon gives a 5 kilogram shell a forward acceleration of 5.0 times 10 to the 3 meters per second squared before it leaves the muzzle. So in this one here, we're going to let forward be represented by positive values. Okay? And since they give us mass and acceleration, it leads us to using the most important equation in physics. There it is, F net equals ma. And we know that's 5 kilograms. And we know the acceleration, now I'm going to use positive because I made the let statement, 5.0 times 10 to the 3. So 5 times 5 is 25, right? So this becomes 2.5 times 10 to the 4. Now look here, kilogram times meter per second squared. But we don't leave it like that. And we got to have a direction. Don't forget about the direction. That's a boo-boo on my part. It's got to be positive that came from the direction of the acceleration. It's the only other vector. But we don't leave it like that. We leave this answer as positive 2.5 times 10 to the 4. A kilogram times a meter over second squared is nothing more, nothing less than a Newton. That is a Newton. So when you're looking at section 2.4, practice question 2, they're asking you to find the magnitude and direction. There's the direction, positive. Here's the magnitude, 2.5. That's an ugly 5. Let me fix that. 2.5 times 10 to the 4 newtons. So a kilogram times let me get a different color. A kilogram, when you multiply it by a meter per second squared, gives you a Newton. So if you take a look here at the other ones, for example, B, you would use the same equation, F net equals ma. You would actually use the same equation for C as well. Now, in B, it says that the acceleration is 2.5 times 10 to the 3 meters per second, E for east. Well, I would make a let statement there. Let east direction be represented by positive values, right? In C, says a 500 passenger Boeing 747 jet gives you the mass there, 1.6 times 10 to the 5 kilograms. Undergoes an acceleration of 1.2 meters per second squared south. So in C, I would say let south be represented by positive values, because your answer at the very end is a vector. So I need a direction and I need a magnitude with the proper unit. Is that helping? Yes? Okay. There we go. Hasta luego.